Today we're going to talk about angles in standard position, both in degrees and radians. Our objectives are to graph an angle in standard position, to be able to convert between degrees and radians, to be able to find complements and supplements of angles, and to be able to find coterminal angles. So how do you graph angles in standard position? Standard position just means that the vertex is at the origin and its initial side is always on the positive x-axis, and then from there we rotate. And wherever we stop is called the terminal side. If we rotate counterclockwise, that's considered a positive angle. If we rotate our terminal side clockwise, that gives us a negative angle. We have our quadrant. Our 0 degrees is on our initial side, and each quadrant is 90 degrees, and that's where we get a full circle of 360. Okay? And we're used to dealing with degrees, and that's what most students are comfortable with. But we're also going to be talking about something called a radian. All a radian is a way to describe an angle by its arc length. We're used to a degree, which tells you how big the angle is, but if you look at that angle inside a circle, a radian is how long the arc length is, or that part of the circumference. So, take the circle and measure, if you took a piece of string and measured out how long the radius was, and then laid that piece of string along the circumference, wherever it stopped is called 1 radian. And if you go around, if you remember from geometry, the circumference of a circle is 2 pi r. 2 pi times the radius, or 2 pi, in our case, radians, is what it is. So we're going to be using the idea that a full circle is 2 pi radians a lot in this chapter. So again, 1 radian is the measure of an angle in standard position. Again, the vertex is at 0 and our x-axis, whose terminal side, the side that stops, intercepts the arc. So this stopping side intersects an arc of length r. And again, the r is the length of the radius. So we're going to graph these in standard position. Our first 3 are degrees. And the way you know something is a degree is because it has that tiny little circle. If it doesn't have that tiny little circle and it's describing an angle, we call it a radian. Now we know these are in degrees. So what we're going to do is graph this. When you graph, you should always have your vertex and your starting or your initial side on the x-axis. We draw an angle because it's a ray. And now I need to get to 237 degrees. Well, a full circle is 360 degrees. A quarter is 90. Half is 180. 3/4 is 270. So I know I'm somewhere in between 180 degrees and 270 degrees. Okay. So how do we show which way we're rotating? We draw an arc, and you have to have this little spiral. So I'm going to take this and I'm going to rotate it 90 degrees, 180 degrees, and it's going to be just past halfway, and that's where I'm going to draw my terminal side. And we draw a little arrow to show which way we rotate it. That's 237 degrees. Okay. What if I wanted to graph 470 degrees? Well, I know a full circle is 360. So here's how I'm going to start. So if I didn't show the swirl, I wouldn't know I'm going more than 1 full circle. So I'm going to draw a swirl showing that, you know what, if I rotate 1 full time around, that's 1 rotation is 360 degrees. Okay, so this is 360. Okay. If I rotate another 90, that puts me at 450. And if I rotate another 90, that's 540. So I know I'm somewhere in between here. I'm actually, here's 450, but I'm only 20 degrees more out of the 90. And that right there is 470 degrees. So what about negative 82? Here's my initial side, but remember, if you're going to graph a negative angle, you rotate not counterclockwise, but clockwise. Well, this is 0. If I rotate backwards 90, this is at negative 90. But I know I only need to go negative 82, so I'm going to rotate 8 degrees less and put a little arrow, and that is negative 82 degrees. Negative 82 degrees. But what if it's in radians? I actually think graphing a radian is much easier than a degree because multiples of 90, and adding all those can sometimes be cumbersome, but a radian is a really easy. I know students don't like fractions, but I think you'll like this a little bit better. So I know a full circle is 2 pi radians from geometry. So this would be 0, half a pi, 1 full pi, because if the whole thing's 2, half of it is 1 pi, and this is 3/2 pi, or 1 1/2 pi. So the main thing you need to remember is we start here at 0, okay, and half a circle is 1 pi. A full circle is 2 pi. So I'm just going to worry about the 1 pi. 1 pi is 1 over 1. But if you look, I want to graph an angle in terms of fifths. So 1 pi is the same thing as 5 pi over 5. So now I know if I go half a circle, it's 1 pi, which is 5 pi over 5. If I go a full circle, that's 2 pi's, or double this, which is 10 pi over 5. But I need to get to 13 pi over 5. Well, I know if I go another half a circle, that's another 5 pi over 5, or 15 pi over 5. All I'm doing is adding 5 pi over 5 each time. So 5 over 5, 10 over 5, 15 over 5. Well, if I'm at 10 here and I need to get to 15, halfway is 12 and a half, right in between 10 and 15, but I need to go just a little bit more, and that is 13 pi over 5. So if you just make your pi fraction the same as your denominator, it makes it really easy. Let's look at our next example. All right, I need to rotate this direction, so I'm going to start off that way so I don't forget. I need to go to negative 7 pi over 4. Well, this is negative pi, or negative 4 pi over 4. Well, I need to get to 7 pi over 4, so this is negative 4 over 4. So if I go 2 pi, that's negative 8 pi over 4. Halfway would be negative 6 pi over 4, but I need to go to negative 7, so that's going to be halfway. So right here would be my negative 7 pi over 4. So what do I do when it doesn't have a pi in it and it doesn't have a little circle? Okay, for my degree mark. Well, if it doesn't have the little degree, it's a radian. All this is this number multiplied out, because remember, pi is just 3.14 and so on. Well, if I type this in my calculator is going to spit out a decimal. This is an example of that decimal. So how would you possibly graph this? Well, I'm going to start at my initial side. I know I'm going to rotate in the positive direction. I know this is 0, and I know this is pi, or 3.14. Okay, half of 3.14, okay, so again, if you're not sure what it is, just take your calculator. Okay, 3.14, and we could just do 2 decimal places divided by 2. 1.57. So just write 1.57. So I know I need to go at least 1.57, but I need to get to 2.5. Okay, 2.5 is actually a little bit closer to 1.57 to 3.14. So, I'm sorry, actually a little bit closer to 3.14. So I'm going to go down here, draw my line, and my little arrow, and that would be 2.5 radians. So how do we convert between degrees and radians? Just like we would convert between inches and feet, there's a conversion. And we know that 12 inches is equal to 1 foot, so when we try to do conversion, we usually do a 1 to 12 or 12 to 1. Well, if we look at our circle, we know half a circle is pi, and that's a nice thing to use, and we know half a circle is 180 degrees. And that's our conversion. We know that 180 degrees is equal to pi radians. So that's our conversion, just like we would have 12 inches equals 1 foot. It's the same idea. So if I want to go from degrees to radians, I'm going to take my degree and multiply by pi over 180 degrees, because then my degree would reduce out and I'd be left with my radian measure. If I have radians and I want to go to degrees, I take my radian and now I do 180 degrees over pi, so that way the radians reduce and I'm left with a degree answer. So let's do a little conversion. If I have 580 degrees, I'm going to multiply by my conversion. I know that 180 degrees, I'm going to put this in the denominator so my degree markings will reduce out, is equal to pi. So how do you do this? And again, we always want to leave pi in our final answer. So all I'm going to do is, if I leave pi in my answer, I'm really just going to take 580 and divide by 180. I'm just going to deal with the two numbers, because remember, this is a fraction times a fraction, so you multiply the numerators. This is 580 pi over 180. I'm just going to reduce. I don't want to use a decimal, so I'm going to math fraction, and I get a final answer of 29 pi over 9. Because remember, I didn't worry about the pi. I just kept this down. I just reduced my numbers. So my answer is 29 pi over 9. How do I convert from radians to degrees? Well, I'm going to take my radian. And since I want the radians to reduce out and I want to keep my degrees, I'm going to put the degrees on the top. Now, again, if I multiply across like we've done already, I have negative 4 times 180. So I have negative 720 pi in the numerator over 7 pi in the denominator. The pi's reduce, and I'm just going to take negative 70 divided by 7, and that gives me negative 102 point, and we're going to do two decimal place, 86 degrees. It's very typical for a radian to be left as a fraction answer, and for a degree to be left as a decimal. So how do we find complementary and supplementary angles, whether it's in degree or in radians? Well, if you remember from geometry, complementary angles are angles that have a sum of 90 degrees. And supplementary angles have a sum of 180 degrees. Or, well, we already know 180 degrees is the same as pi. So if we're in degrees, they should add up to 180 degrees. If they're in radians, it should add up to pi. Well, since we knew this from our last conversion, if they have to add up to 90 degrees, that's half of 180, it must add up to pi over 2. So 180 degrees is the same thing as pi, just as 90 degrees is the same as pi over 2. So how would we do this? Well, a lot of students don't know how to add and subtract. This is what I like to think. Complement of 68 degrees. So that means 68 plus something should equal 90. Just put an x in there. Do your algebra. Subtract 68 from both sides, and I'm going to get 22 degrees. So the complement of 68 degrees is 22 degrees. Well, what if I wanted the supplement of 115? Well, if I take 115 plus something, should equal 180, because supplementary angles add up to 180. Okay, call it x. So if I subtract, let's see, 65 degrees. And your answer always needs to be a positive answer. You can't have a negative complement or supplement. But what if we're in radians? Again, it's the same thing. I know 5 pi over 8 plus something should equal 90 degrees. But we're in radians, so that's the same as pi over 2. So if I want to solve for x, all I'm going to do is subtract 5 pi over 8 from both sides. So if you remember, you get when you have fractions, you have to get a common denominator. My common denominator would be 8. So this is the same thing as 4 pi over 8. Well, if I have 4 pi over 8 minus 5 pi over 8, I get negative 1 pi over 8. All right, but we had a negative. That's bad. Okay, a negative doesn't really mean negative like what we're thinking, like a negative number. Negative, when we're talking about angles, is a direction. So I can't say that this angle plus this negative angle gives me pi over 2 necessarily. We don't like to do it that way, so we usually just say this has no complement. Okay, because we're not going to really do a rotation backwards. Okay, so but what if I wanted the supplement? So let's think about that. Supplement means I take my angle plus something should equal 180 degrees. Well, in this case, that's the same thing as pi. So if I want to find x, that's just going to be pi minus 2 pi over 11. So if I want to get a common denominator, that'd be 11 pi over 11. 11 pi over 11 minus 2 pi over 11 is 9 pi over 11. It's positive, so that would be my supplement. Whether it's radians or in degrees, sometimes you'll have an answer, sometimes you won't. Again, we usually don't typically keep our negative answers, so we'll just write no complement. If we get a negative in a supplement, we would write no supplement. The last thing I want to talk about are coterminal angles. Coterminal angles are angles whose terminal sides coincide and can be found by adding or subtracting multiples of 360 degrees, if we're in degrees, or, well, 360 is a full circle, and we should remember that a full circle is 2 pi radians, or 2 pi r, like our geometry for circumference, in radians. So what does this mean? The terminal sides coincide. Well, remember, the terminal side of an angle is wherever your angle stops. So say I do a swirl and I stop right here. This is my terminal side. So that means that as long as the terminal side of another angle stops right at the same place, they're called coterminal. So the only thing that's going to be different is the swirl. I might swirl positive. I could do another angle going in the opposite direction. What if I swirled, kept swirling, swirling, and then stopped? That would be a coterminal angle. Well, since the only thing that changes is the number of rotations, so picture facing this direction. What would you have to do to face that direction again? Well, you would do a spin, and a spin is 360 degrees if we're talking about degrees. If you'd done it a whole bunch of times, you're just doing multiples of 360. But if you're in radians, one rotation isn't 360, it's 2 pi. So all we're going to be doing is adding and subtracting 360 or 2 pi as many times as we want to get another angle that's in the same position but has a different value. So let's look at our two examples. If I have an angle at negative 400 degrees, and you don't have to know what that looks like, but if you wanted to know, negative 400 degrees, okay, so this is negative 360, but we have to go 40 degrees more to get negative 400. This is negative 400 degrees. So I want another angle, one positive and one negative, that look the same but have a different number. So you don't have to redraw it out, but just think, if I'm at negative 400 and I want a positive answer that looks, or angle that looks the exact same, all I'm going to do is add 360. Because what's that going to do is, instead of having a negative rotation, it starts to rotate in the positive direction. Well, if I add those, I'm still going to get a negative 40. But that's not a positive answer. So what could I do? I'm going to spin again. So I'm going to add 360 again. If I add 360, I get 320 degrees. That is a positive angle. That would look exactly the same as this. 320 degrees would stop right there and have the same terminal side. Well, what if I want to find a negative one? Well, if you notice, I already actually had a negative coterminal angle. Negative 40 is the same. But typically, all you do is have to add 360 until you get a positive answer, subtract 360 until you get a negative answer. So that's negative 760 degrees. If I graph negative 760 degrees, it would look like that. It's a different number of swirls, but it ends up in the same place. So if you remember in degrees, add 360 till you get a positive, subtract 360 till you get a negative, and it'll always work. But what happens if we are in radians? I need to do rotations, but rotations are 2 pi. So I can keep adding 2 pi until I get a positive number. Well, I need a common denominator, so this is 11 pi over 8. Plus, if I make the denominator 8, this is 16 pi over 8. I have a common denominator of 8. 11 plus 16, 27 pi over 8, doesn't reduce, so that would be one positive angle that looks exactly the same as 11 pi over 8. But what if I want a negative one? Instead of adding 2 pi, I'm going to do a negative rotation, so I'm going to subtract 2 pi. Well, if I subtract 2 pi, that's 11 pi over 8 minus 16 pi over 8. And that gives me 11 minus 16 is negative 5 pi over 8. So I only had to do it once each time, which made it really nice. I have one example that's positive, one that's negative. I hope you feel a little bit better about angles in standard position, whether in degrees or radians, that you feel that you're able to graph it, able to convert between degrees and radians, able to find complements and supplements of angles, and to be able to find coterminal angles.